Welcome everybody on Zoom. Welcome everybody in the lecture hall. So what's on the menu for today? I will first finish what we started last week with data definition with SQL. That was a practical part where we dived into the SQL language and how to actually create your tables in PostgreSQL. We saw how you can create tables, drop tables, modify tables by adding columns. We saw a list of plenty of types that you can use directly in PostgreSQL. We saw how you can add data to your table, insert the data, and so on. But I still was not completely done because there was the consistency constraints that I needed to finish. So what I'll do, I'll not ask the clicker question right away. I'll first finish with this, then we'll start with the relational algebra in the second part. All right. So to finish what we started, I wanted to come back on all the things that even I learned with you last week. So I will upload a new version of 2 slides here that I modified. So you remember that for the char3 or char-n type, the behavior with spaces was a bit fishy. So what happens is that it's really meant, when you say char3, it's really meant for 3 characters, like not spaces, like airport codes, for example. So the normal use would be the foo, F-O-O. But if you try to insert into the type char3, so this first column here, something that's smaller, like the space F and so on, then the behavior is not very clear because it kind of doesn't add spaces here. If you have extra spaces, it seems to be removing them for some reason, and the behavior is not consistent. So what I did is, for the purpose of the course, I put that in orange as a warning that this is not supposed to be used in that way. Right. So if you have char3, it's really for country codes, you know, that sort of things where you don't have spaces, right? So avoid having spaces in there and you'll be safe. Of course, with varchar, spaces are fine. They are part of the string and will be truncated, but I just wanted to quickly come back on that. Is that clear for everybody? Yes? I assume yes? Okay. The second thing I wanted to also clarify and come back to is that when you have numeric, or decimal, they are equivalent, you have these 2 parameters. The first one is the precision, and the second one is the range. So the precision is the total number of significant digits. You know, especially for physicists, probably it makes sense, right? Whenever you compute something, you have only so many digits that are actually significant. The rest is just noise. For example, if you compute the distance that the Earth is orbiting around the sun, and if you compute that with a precision of a millimeter, it doesn't make any sense, right? Because there's no way that this makes any sense because of the fact first that it changes over time. So it's the same here. Here we say we have a precision with 3 digits and no more than that. And you can also say that you accept 1 digit after the comma. What you need to understand is when you say that, 3 and 1, you are implicitly defining a third parameter that is 3 minus 1. Because what you're actually doing is you're saying there's 3 digits in total, 1 of which is after the comma and 2 of which are before sorry, I'm saying comma in French. So before the decimal periods, right? So there's 2 significant digits before the decimal period and 1 after. 2 plus 1 gives you 3, right? So this is what you need to understand. So what that means is if you try to insert here numbers, then you can have more digits after the decimal period that are beyond what you accept after the decimal periods. For example, here, 3, it's implicitly 0, right? So you have 3 significant digits before the decimal period and 0 after that. So it's just going to truncate, right? Everything that's after the comma, it can just truncate. So this is why the 0.1 and 0.14 goes away, and that ends up with 3. Here it's also truncating, but here you have a range of 1. So 1 digit after the decimal period and 2 before, 1 plus 2, 3. So this is why here it truncates at 1 after the decimal period, right? Is that here, this truncation? All right. What will not happen, however, and this is a design thing, is that it's never going to truncate for precision before the decimal periods. So if you say numeric with 3 significant digits, as a physicist, you would say, okay, it means that the 3, the 1, and the 4 are significant, and the 1 and the 5 are just noise, right? So you could think one way to handle this is to round this to 3,140, and you just put zeros everywhere else. You just take the first 3 digits. That could have been one way to design it, but it wasn't done that way. Instead, it's throwing an error because you really, when you have 3, it's really 3 digits before the decimal period. There is no 4th digit, right? It would be totally unable to store 4 digits before the decimal period. So this is an error. And the same here, it would have to be at most 2 on the left and 1 on the right, but it never truncates on the left of the decimal period. So here, it could have truncated to 3,100, but it doesn't, right? So this is an error, and you cannot do that. Is that clear? Okay, just wanted to come back on that to basically make it even more precise. And there is a third thing that I wanted to confirm because I experienced it after the course, because somebody asked, what happens if you add a new column to a table, which by definition is empty, right? Because you're adding a new one. What happens if you define that new column to not allow nulls and without any default value? The answer is it throws an error, right? Because you can only add a column if you can put something by default in that column because it's new. So if you allow for nulls, it's just going to put nulls everywhere. If you have a default value, it's going to put that default value everywhere. For whom is that clear? Okay, wonderful. So this is just, we came back to that. And Andrea just confirmed, I see on the chat on the screen that the slides were just put in the Moodle, right? So you can access them. Thank you very much, Andrea, for that. Okay, this is now new. These are the consistency constraints, and that's the last part of the lecture on Postgres. Excuse me, on using SQL and PostgreSQL to define your tables. These are the benefits of a relational database management system that you otherwise wouldn't get if you just try to hack around with Python or another language. These are features of a relational database. So we'll look into 3 of them: forbidding nulls, checking some constraints, and unique. Well, I have good news for you because we've already taken care of the first one. That's something that I've already shown you. It's this idea that when you define the columns of a table, you can write not null after the type. So you say here that you define a column called name with the type text. So it means string of unlimited length. Not null means you cannot have any nulls. It has to be a string. The string can be empty, of course, but it cannot be null. So this is a way to constrain things, right? So if you say not null, then you are not allowing the nulls. If you don't say anything by default, it's allowing the nulls, right? So this is the default behavior, right? So this means that if you look at this table right here, then I put these little checks and crosses here. So this null here is not fine because you're forbidding name to be null. So this would be forbidden. PostgreSQL will not even let you do that. If you try, you will get errors. The database will never be in a state that this is null. It's a guarantee. If you try to read it, there will never be a nulls in there. But this null here is fine in the column student. Why? Because since we didn't say anything, then nulls are allowed. All right? So this is null. There are 2 ways to interpret null in theory, because you might remember that the week before we had done theory of relational model, right? This is the practice, but we've looked into theory before. So how do nulls fit in this theory? I think there are 2 ways that you could theorize the nulls in the relational model. The first way you could theorize the nulls is by interpreting that as a missing value. It basically means that you remember a table is a set of maps, right? And the maps have a support. And we require the support to always be the same. For example, in that case, every map in the table should have name and students as attributes that get mapped to a value. Well, you could interpret nulls as a slight relaxation of that. It means that in that case, the support of that map is just name and not student. And that would be a breach of relational integrity, right? If you interpret that null as the fact that student is not even in that map, that would breach relational integrity. But you could say we tolerate that, right? So we enforce atomic integrity, we enforce domain integrity, but relational integrity, we kind of make an exception if it doesn't happen too often, right? So we kind of tolerate that some of the maps might be missing one of the attributes or several of the attributes, as long as the total number of attributes in your table is reasonable and that you have a schema like that. For whom does it make sense? Right? So it's a slight tolerance in the fact that some of the maps might have a smaller support, right? This is the first way to interpret the nulls, but there is a second way to interpret the nulls that is just as good, where you say we do not change the relational support. We still require all of the maps to map exactly the same attributes. But what we do is that we consider that null belongs to the domain of acceptable values of all the attributes. So null is just a value, just like 1 or 2 or the string foo. Null is another value. If you do that, then these same records that we looked at right here with foobar and null, you would interpret that as mapping name to foobar and students to null, which would be a value belonging to the domain, right? So again, if I summarize, null can either be interpreted as the absence of value, meaning it doesn't belong to the map, or it can be interpreted as a special value that you add to the domain, right? So when you say integer, you actually mean integer union the value null, the singleton set null, okay? For whom is that clear? Very good. So this is the theory of nulls. And you see theory and practice, right? We saw the theory, we saw practice. You know this saying, right? Theory is when you know everything and nothing works. Practice is when, Theory is when things don't work and you know why. Practice is when things work and you don't know why. And putting theory into practice is that things do not work and you do not know why. It's one of the sayings that I like. But anyway, let's continue with the second one, check. Check allows you to add your own conditions. For example, you could require that the name cannot be Spock. This little smaller than, greater than is just a difference than character. So here you would forbid the name to be Spock, and it would disallow this row right there, right? So that could be an example. So this is the check constraint. And again, you're giving the responsibility to the database management system, to PostgreSQL, to make sure of that. And as a user, you can rely on these guarantees because it's going to be making sure that this doesn't happen. Okay. Now the third one, unique. What unique does is that it makes sure that the same value is not going to appear several times in your table, in the same column. So if you say name is unique, you're never going to have twice the same name. So in that case, this is a breach. It will not let you do that. You have twice Spock in name, but if you say unique, that will be forbidden, right? That can never happen. Student doesn't have unique, so you can have here true, and that's fine, right? And here, AHV, so that's the social security number in Switzerland, would also be unique, but here you can see they're all unique, so this is fine, right? Does it make sense? All right. I think a common question is what with nulls? What happens with nulls? What I think, and maybe Andrea, you can try in the background, what I think is that if you have a field that is unique, but you allow for nulls, I think you can still have plenty of nulls. What must be unique is the non-null values, right? I would say I'm 90% confident of that. Maybe we'll get a confirmation a bit later. Okay. Okay, these are the three: null, not null, check, and unique. Now let's move over to the concept of primary key. This is a concept that we will study in depth with a lot of formalism in a few weeks in database design theory. We'll look into how to find out and resolve the primary keys of a table. But now I'm explaining to you today in an intuitive way. A primary key, when you have a table of records, is an attribute or several attributes that uniquely identify a record. And this is very intuitive to understand because imagine you're in Switzerland and you're the tax office and you have the database of all the taxpayers. Then what are you using to identify a taxpayer? So typically the social security number, right? Anything derived from that. So it's the AHFAO number. So you could say, if you have a database of people, that the AHFAO number would be a primary key of that table, right? Because a AHFAO number uniquely identifies a person. What that means is that it cannot be null. You have to have a social security number if you pay taxes. If you don't have any, they will give you one. And it must be unique. You cannot have two people with the same AHFAO number, right? That is not possible. Okay, but then you could think, okay, if my primary key just cannot be null and must be unique, then there is no need for something new, right? We just say unique, not null, and we are done with it, right? We already know how to do that. So we could do it that way. And then we get something like this. Okay, so there is actually more to it because we want to be able to reference the primary key in foreign constraints. So it means that we have a special notation for that that's just called primary key. And that allows you to define the attribute, so in that case, AHFAO, as the primary key in there. An alternate way of doing that is to put primary key at the end with the name of the attribute. It's the same thing, all right? And finally, you can also define several attributes jointly to be your primary key. The first name plus the last name are together the primary key, which may or may not make sense because, as you can imagine, if you have an entire country, it's bound not to work. You will have people with the same first and last name. So this is really just an example. Okay, in that case, you have both the first and last that identify them. Is there a question?
Yeah, so when we put primary key, it is by default unique and not null.
It is even by definition unique and not null. Yeah, you cannot even change that. You basically cannot define a primary key that wouldn't be unique or that would allow nulls. Does it answer your question? Okay, wonderful. Okay, so this is primary keys. But the whole point of primary keys is that you can actually reference tables. And for example, you could have here a table of taxes with the fiscal residence, with for every social security number, you have the actual residence. And what that means is that the value that is in the first table in the AHFAO column actually identifies a person in the second column. So you kind of have a link between the two tables. You're linking them together. And we'll see how this is actually done, actually just in the next part of the lecture, what we can do with these two tables it's called the join. But basically you can reference in a table the value here and link it to that table right there, okay? It's fine also, oh, I don't have it here. Okay, it's coming later. I wanted to say you can have nulls too in there. But how do you do this? You basically add, when you define this table right there, that this column AHFAO references the table persons and in particular column AHFAO, right? So this is how you link taxes AHFAO to persons AHFAO, and this is how you do that, references persons AHFAO. If you don't specify the column right here, then it takes the primary key. This is one of the benefits of having a primary key in the table person, is that you can, by default, reference it without the need to specify it right there. Okay. You can also have duplicate references. Some people, I don't know, might be taxable in multiple countries. So you can absolutely have duplicate references. Why? Because again, this column right there is not a primary key of the table taxes. It's a foreign key. That's not the same. It's pointing to a primary key in another table, but this is not a primary key of that table. This is why it's fine to have duplicates right there. Okay. Next, you might have multiple attributes jointly identifying a person, and that means that you can also have multiple attributes together that are a foreign key, right? In that case, you say the foreign key, you have to put it at the end because it's on multiple attributes, so it's on the last line. Foreign key first, last, references persons first, last, and that's it, all right? Next, nulls are fine. You can absolutely have foreign references that are nulls. So you see, primary keys cannot be null and must be unique, but foreign keys can be null and do not need to be unique. Okay. So next, you can delete referenced values. But the question that you have to ask yourself then is, what do we do with the foreign keys? So if you delete a table that has a primary key that are referenced from other tables, how do you deal with these broken references, right? So for example, if you delete here Kurt Gödel right there, what do you do with the other table pointing to this person, right? So what do we do here? Well, there are several ways of doing that. The first strategy is called cascading. If you delete the attribute with the primary key, it's going to cascade the delete and also delete the records with a foreign key pointing to it, right? In that case, you just say, when you reference persons first last, on delete cascade. You can also forbid it, on delete restrict. So if you have pointers to this person, then you just forbid the whole thing and do not even let the user delete the person. And it's just going to say, okay, it's already referenced somewhere else, so you cannot delete it. A third strategy, you have the choice, right? The third thing is set it to null. So if that person is removed, then you just replace the foreign reference here, the foreign key, with null and null, which we saw is fine. Okay, that's the fourth strategy. And finally, the fourth strategy is to set to the default value. So for example, if the default value for first and last is Albert Einstein, then you just populate and replace with Albert Einstein, right? The default value. Okay, that's it. That's the end of this, this lecture on PostgreSQL. Do we have questions? I think it probably would, and it would probably already throw an error when you try to do the schema of the table. So I think that if the table persons right here, if there is no default defined, then this will already throw an error at schema time, right? Now that you asked the question, I have a doubt suddenly if it takes the default of first and last in the table persons, or if it takes the default of first and last in this table right here. And now I have a doubt. I'll actually look it up. But basically, I would expect that if there is no default, it will complain and throw an error. The other thing that could happen, that's actually interesting, if you consider that by default, the default is null, right? If you don't set any defaults, then the default is null. So it might also be that this actually puts nulls in there. But these are interesting things that we'll investigate and get back to you. These are interesting details, right? So you see, I don't know everything. The PostgreSQL is a very big piece of software, and it's really good that you ask, because every time it allows us to dig into it. Okay? Yes?
Yeah, something similar. If the default here is Albert Einstein, and what if the courses table doesn't allow the same person twice?
Oh, but it does, because it's a foreign key. So when you define a foreign key, you would typically allow multiple persons. I could, however, and this is why it's a good question, I could imagine a design in which you define the foreign key, plus you add a uniqueness constraint on the foreign key. And then indeed, if there is a default, then it will create a problem. And that's actually a very good point. Then you would probably also trigger an error, because setting to the default, if it's already used somewhere, will trigger an error. However, what I think, and what I would recommend is, if you have a column or an attribute that is unique, it's probably not a good idea to have a default value. You should let null be the default value in that case, right? That's my recommendation. Sometimes just, even if you can, doesn't mean it's a good idea to do it, right? Yes?
I am actually don't understand why you introduced this concept of foreign key.
Foreign key? So how can I'm trying to basically answer without doing the lecture that we'll do in a few weeks. The idea is that you could not use foreign keys or primary keys and put everything in the same table. You could have a big table. The problem is that it creates a lot of issues. if you try to have a single table where you put everything, you're going to end up duplicating data. And when you start duplicating data, a lot of problems start happening because you could actually fix data somewhere, but you forget to fix it somewhere else. So then the duplicates are inconsistent and so on. So what you do is that you split the tables into several tables to fix the issue. But when you do, you need to retain a link between the tables. And this concept of primary key and foreign key is very central to relational models and relational tables theory. You very rarely have a single table in your database. You typically have many of them, maybe 10 or even 20 tables, typically in a company database. And these tables reference each other. So this is why the concept of primary key and foreign key is very central in a relational database. Right? Did I answer your question? We'll spend probably 2 or 3 weeks diving into these things and looking into how to split tables and you know, there is a whole theory with normal forms for that. But how to connect these 2 tables together, that's called the join. And this is something we probably will see either today or next week, right? Okay, yes? Which slide? This one? Yeah. So what happens is that if you define the default value for your foreign key, and in the table persons, it just goes away and disappears, then in that case, you replace. You see, it used to be called Gödel here. So we replace that with the default value, which points back to the right person. Yes, exactly. The default value is defined as we've shown before with this default blah, blah, blah. Right. And I will come back to you. I think, sorry, I think it's probably the default in the table courses. It would be strange to have a default for a primary key. So it's probably the default of first and last in the foreign keys. Oh. So it's the default that you define for column first and column last. So you would have, in the same schema as here, you would have the definition of first and last, and you probably would have first default Albert, last default Einstein. So basically, I think what might be confusing is that what I put here is only a portion of the schema. This is not actually the complete command. It wouldn't work like that. What I should have done, and maybe I update the slide, is to write the complete schema, the entire schema, and then you will see everything. You will see the default, you will see the foreign key. Yeah, that's a very good suggestion. Yeah, thank you for this. Yeah. Okay. Okay, so let's move on then to the relational algebra parts.
So while you switch slides, maybe the question asked before, which is whether you can have multiple nulls in a column with unique, and yes, you can. So
yes, you can. Okay.
The values that are not null need to be unique, but if you have no multiple nulls otherwise.
Okay, thank you for this. Right, so that answers the question earlier. Thank you very much. All right, so I'm going to stop the recording of this part right here, and then I'll be back in just a few seconds with the relational algebra.